In this section, we'll look at eliminating unreferenced data. Specifically, what we want to see is how is data that is no longer referenced eliminated from the system. This is one of the few places where each vendor chose a different way to solve the problem. Pure uses a process called reference verification. During recycling or garbage collection, Pure checks the mapping table at the original location a block was written to see if it is still referenced. They also need to check their link table, which is what tracks foreign references to the block from other volumes, for example, due to deduplication. If no references to the block are found, it can be safely eliminated. Extremeio uses a process called reference counting. In this method, each entry in the block metadata, that is the block ID to location mapping table, contains a reference count. Every time an existing block is written again, or referenced again, that reference count is incremented. Each time a block is overwritten or deleted, that reference count for the old block is decremented. Operations that trigger significant data changes, those would be things like volume deletion, volume cloning, or any sort of XCopy process that duplicates data from one volume to another, will trigger a background operation to update the reference counts. Doing this takes the performance of having to do all of those individual reference counts out of the data path and puts it onto the storage controllers themselves. Blocks with 0 reference count are subject to being overwritten the next time a stripe update happens. SolidFire uses a process called mark and sweep garbage collection. For every entry in the block metadata, that is the block ID to location mapping table, there's an in-use flag. On a regular interval, all blocks are marked as not in use, every one of them. The volume metadata creates a Bloom filter of currently in-use block IDs and sends that to the block layer. Any block that's present in that Bloom filter gets marked as in use. So essentially the entire array gets marked as not in use, and the Bloom filter goes through and specifies for which values that's not correct. The blocks that are not in use at the end of garbage collection are removed during the recycling process. In summary, this is one place where all 3 vendors chose a different solution to the problem. Reference verification requires a tight coupling between the storage layer and the metadata layer. On the upside, it allows for near-instant determination of unreferenced data, and where blocks can be deduped, the lookup to do that is fast and easy. This is best for architectures where all metadata and data are globally accessible by all of the controllers. Pure's dual controller architecture works perfectly for this. Reference counting has a couple caveats. The first is that it requires large updates to any reference count, especially those created by certain operations like deletion, cloning, or XCopy, to be batched up and run in the background. The second, and more important, is that it requires perfect consistency in reference count updates. If there's a delta between the number of blocks that are actually referenced and their reference counts, data unavailability or data loss is inevitable. It allows near-instant determination of reference data and is really best for architectures with a single source of truth for the metadata. Mark and sweep garbage collection requires a background garbage collection process. This isn't something that can be done inline, and it isn't something that can be pushed to the drives. It's very tolerant of system disruption. Failures of disks or failures of nodes have no impact on the metadata management and the unreferencing of data. This also allows volume metadata manipulation without having to go to the metadata and make significant changes. This solution is really best for loosely coupled distributed systems.